Hi everyone, this is lesson 514 on writing equations for quadratic functions. So technically we've been writing equations for the past few lessons. Just every time we were taking a different approach. In this lesson, we're focused on taking the table and turning it into an equation. All right, so that's going to be our goal on this lesson. But before we could do that, we need to kind of use what we learned in the previous lesson to help us. So I'm going to go over that again. So if you didn't watch that one or you needed a refresher, this should help. So here we're going to be using our zero product property to solve this equation, which I'm going to review this mainly so that we could see how we could possibly reverse this whole process to end up with an equation. So in this example, or this is from problem 38A, they start us off with an equation in standard form, a quadratic equation in standard form, and our goal is to end up with solutions to this and maybe even x-intercepts. So I've done pretty much the work for us on this one. So most of this will just be copying down. So it would probably start with us factoring. So our goal is to get it into factored form. So if you have other means, if you know how to do, there's different ways of factoring. So if you know how to go straight to factored form, that's fine on this problem. But for the most part, this approach that we've been using, using the area model, using the x to factor, you should probably be using this. So the goal was to get the dimensions of the outside of the area model, which are in the factored form. So x plus 2, x plus 4. So you'll notice I'm still keeping this equation, it still says equal to 0. In zero product property, what zero product property tells us is that we can take both of these factors and separate them into their own equations. Right? So that's what I've done here. So one of these must be equal to 2. One of these must be equal to 0, or both of them can be equal to 0. So in this case, if I set x plus 2 equal to 0 and I solve for x, I end up with x equals to negative 2. And if I set x plus 4 equal to 0 and I solve, I end up with x equals to negative 4. All right, so those solutions are what we call zeros. Right? So that's a reminder of that term. Zeros means solutions. So x equals to negative 2, x equals to negative 4. The nice part about the answers here is that they also help us get our x-intercepts. So that's kind of like bonus information, right? This is extra, which we're actually going to use in this lesson. So if I just say to solve, then we would stop here at the zeros. But if I ask you for x-intercepts, then I would rewrite it. They're pretty much the same numbers for your x values, except we're going to write it in coordinate form. All right, so the reason why we need this is because if we are able to solve this equation and determine the x-intercepts, well then maybe we could take those x-intercepts and work backwards to get our equation. So if we could go from here to here, then maybe we could go from here back up to here. So maybe there's a way to go backwards in this process. And so that's what we're going to try to do moving forward. All right, so let's start with, even though the focus of this lesson is on the table, we're getting there. That's going to be the next step. But before we could appreciate the table, we need to know just how to write an equation. All right, so let's see, this is a good spot. All right, so writing a quadratic equation given x-intercepts. All right, so I've given us 2 x-intercepts. It's possible there could be A quadratic could have one x-intercept, it could have none, actually. This is assuming we have two, and we're going to work with that information. All right, so just like the previous problem, in order to get our x-intercepts, we needed to know the zeros. So let's just go backwards. All right, so we could take those x-intercepts and write them as zeros. All right, so in this case, I have a 1, so that means x equals to 1. I have a -3 in my x-intercept, so that means x equals to -3. Well, in the previous problem, we started with this and we were solving for x. Now let's see if we could go backwards. So let's rewrite the equations so that they're equal to 0. So if I want x equals to 1 to end up being some equation equal to 0, means I need to subtract 1 from both sides, and then 1 minus 1 is 0, right? And then x minus 1 stays as x minus 1. All right, so it's kind of like we're just undoing this whole solving equation process. And so the same thing with the second factor. All right, so now that we have these two equations, right, from our x-intercepts, we created two equations. What we do know is the zero product property says that those two, when multiplied, equal to 0. All right, so this is like the reverse of the zero product property. Before we were separating them into two equations. Now I actually want to bring them together to form one equation. All right, so now if you think about it, we've taken these x-intercepts and we've already gotten to the point where we have one equation. All right, so the only thing missing really is the y equals portion. So all I'm going to do is rewrite this so it says y equals, and in those same factors. And what we have here is it's a possible quadratic equation. Means this might be the exact equation for these points, or maybe there's a similar one to this one that goes to these points as well. All right, but we do know it is a possible one, and this is in factored form. Right, you'll notice it's in factored form, which is perfectly fine. Right, if you put that into a graphing calculator, it'll graph it just the same. All right, so if we want a more specific or exact equation, we would need more information. All right, so the nice part is we could get that from the table points. So this is how we're tying in the table. So the table, not only could it possibly give us x-intercepts, but it might actually give us more information, more points that we could use to find an exact equation. All right, and so this first example with a table, let's see. So let's try this with a table. All right, so if we're given a table of points, now a table could be written horizontally or vertically. In this case, it's horizontal, so we have our x's and our y's, right, separated. So on the top is all our possible x values, and then on the bottom is all the possible y values, just so we're clear. And then each of these together would represent a point on the graph. So like this first one would be -4, 6, all right, and the next one would be -3, 0, etc. All right, so just for clarity on that. And so what we're going to do is we're going to look for key points. So we're just looking, we've been given a lot of information and we're going to take what we need. And so the most important for us, just like the previous problem, is if we know the x-intercepts, then we could write an equation. So let's look for the x-intercepts. And so x-intercepts are easy to find because they're all the places where y is equal to 0. That's how I know where the x-intercepts are. So I look for y equals to 0 there, y equals to 0 there. Another good point to have that may or may not be in your table is the y-intercept. So you'll notice this one has x equals to 0 on this one, so it's the reverse. So these are 3 key points that might be worth taking from your table. All right, so The next step is let's take those x-intercepts and write a possible equation. This is exactly what we just did on the previous problem. So I'm going to take negative 3, 0, and I'm going to start with x equals to negative 3. Right, that's one of the zeros. And the other x-intercept is 2, 0, so that's going to give me x equals to 2. So I'm going to do the same steps. I'm going to rewrite these so that they're two equations equal to 0. I'm going to combine them into one equation, just like we did before, using zero product property. And then that leaves us with, I'm just going to rewrite it as y equals to x plus 3, x minus 2. If for some reason you eliminate all this stuff, if you eliminate the y equals, if you write an equation of 0 equals, I would mark it wrong. If you eliminate the equal sign and everything, it's wrong. Our goal is to write an equation, right? But is it the correct equation, or is it just a possible one? At this point, it is just a possible equation because we don't know if even the other points work. So one thing you can do, you actually have a choice. You could choose any of the other points on the graph besides the x-intercepts, and you could just plug it into the equation and see if it works. If these points work, then that must mean most likely this equation is correct. If you plug in more than one, then that'll for sure verify that it works. All right, so let's verify the equation by plugging in a point. And a good one to plug in, I think, is the y-intercept, mainly because it has a 0 in it. All right, it's a lot easier to do calculations. And so this is what I'm going to do on this one. So instead of y equals, I'm going to replace y with, here, let me label this. So in the y-intercept, this is going to be like our x and y, right? This is our x and y. So x equals to 0 and y equals to negative 6. So I'm going to put in negative 6 for the y, and then every place where there was an x, I'm going to replace it with a 0. All right, and that's it. And so the whole point is just to see if it works. And so I simplify this. 0 plus 3 is 3. 0 minus 2 is negative 2. Be careful there. Not 2, it's negative 2. And then when we multiply those, they give us negative 6. Right? So you'll notice both sides of the equation equal each other. So therefore, this works. Right? So that's good. That means most likely this is our final equation. So then I would accept this as our final equation. All right. All right. So let's look at another example. So like I said, keep saying this is a possible equation. This is there might be others. Well, this is the most ideal situation where it just works out nicely, but that might not be always the case. So we're gonna look at one where it's a little bit different. And since it is possible to have more than one equation that goes through the same x-intercepts, we need to always determine the correct one. All right, so and I'll leave it like this. All right, so we can see both. So I'm giving us this new general formula or equation to look at. So you'll notice it looks very similar to the equation from the previous problem. The only difference is I've introduced this new letter in the beginning. All right, so if I put another number in front, that's going to change everything. Right, so if I put a 2 in front, that's going to make everything twice as big. If I put a 3 in front, that's going to make everything 3 times as big. If I put a 1/2 in front, it'll make everything half as big. And so if I put a number in front, it's going to change the size of all the y values. But you'll notice the x-intercepts will stay the same. And so we're going to look at an example where our a value is going to be a little bit different than the previous one. So the previous example, our a value was equal to 1. So we didn't really notice a change. So let's look at this table and see where it leads us. All right, so here's a table. Looks similar to a previous problem. So I'm looking, first thing would be look through it, find key information. So I've already highlighted our x-intercepts. I've also highlighted the y-intercept, but I'm not going to label that. But I've written out our x-intercepts. All right, so the first step would then be to take those x-intercepts and write them as zeros, and then do some simple calculations to write them as equations. Right? So you'll notice I'm doing simple algebra steps just to make sure I get my equations correct. So this turns into x plus 3, right? Even though it says x equals to negative 3, you'll notice now it says x plus 3, and then x equals to 2 turned into x minus 2, right? So now that we have the two separate equations equal to 0, we could rewrite this in factored form using the zero product property. And now this is the new part. So I'm going to write this in factored form, but you'll notice I've put this a in front. Our goal right now is to figure out what a is. If we can figure out what a is, then that's it. Then if it's a 1, then we just leave it alone. We can get rid of the a. If it's a 2, we put a 2 there. If it's a 10, we put a 10 there. So let me show you how to do this. So this is the only part that I haven't worked out yet. So this is where it becomes key to use really any of our other points in the table. And so I mentioned before, sometimes it's easier just to use the y-intercept. So that's what I'm going to use at this point. So our y-intercept is going to be, this is what, 0, negative 12. All right, so I'm going to plug in negative 12 equals 2. So I still have my a value, and then I have something plus 3 and something minus 2. So that something is going to be 0. That's from my y-intercept. You could use any of these other points. So if you wanted to use these other points, you could use those as well, and it'll still work. I think just y-intercepts could be a little bit easier for some people. All right, and then let's just simplify this. So this is negative, I'm going to rewrite this, negative 12 equals to a times, so 0 plus 3 is 3, and then 0 minus 2 is negative 2. All right, so you'll notice I'm still keeping the parentheses. I still need to know this is multiplication. You are not subtracting these. This is not 3 minus 2. So I encourage you to always keep the parentheses until you've completely multiplied everything out. All right, so at this point, this is going to be, so 3 times negative 2 is negative 6. Right? So this is negative 6 times a. Negative 6 times a. Let me move this up. Let me zoom in. So this is the part where we need to divide both sides. We're going to divide both sides by negative 6. And when I do this, you should notice that negative 12 divided by 6 is positive 2, and this right side reduces to 1, which means is equal to a. All right, now we figured out what a is, which is exactly what we were looking for. Oops. So what I'm going to do is I'm going to take that, and we're going to finish our equation. Y equals 2. I'm going to put 2 times x plus 3 x minus 2. So you'll notice here that we have the a value, right? We've put the a value in front, and the factors, this was the original factors that we had solved for. Right, so this is, you'll notice, really the work's not that long. If you ignore the table and you just look at this work right here, you'll notice this part was really simple. Really, it's not even a lot of calculations, it's just organizing it just till we get to this point. And then the key part was making sure you put an A there. That way you have something to solve for, and then making sure you have this third point. So we mentioned earlier, well, it's nice if you have the x-intercepts, but you need something else, right? So in this case, another point, any other point on the graph would help. And that is what you need to know how to do. So this is kind of, this last problem kind of summarizes what you need to be able to do. Take a table, and write your final equation. Right? So this is our quadratic equation. All right. There you go. Hopefully this made sense. Let me know if you have any questions. The next lesson, you'll have some more practice of this as well.